Hey everyone, my name is Josh Gomez.
And I'm Jessie Frazelle.
We're from Kitty Cat, and today we're in Pasadena, California.
We're at Launchpad, and they do automatic assemblies with fasteners, dispensers, lasers, and a whole lot more. We're going to be checking out their machines and talking to a couple folks here about what they're building.
Let's head inside.
Hi, I'm Jess.
Hi, Jess.
Pleasure to meet you. I'm Josh.
Hi, Josh.
Can you tell our watchers a little bit about yourself and about Launchpad?
Sure. I'm Yoav. I'm the CEO of Launchpad, and we are building self-programming robots to reshore manufacturing back to America.
Fantastic.
That's awesome.
Let's go see it.
Hey, yo, how you doing, sir?
Great. Good. Guys, this is Josh, one of our systems engineers.
Hello, Jess. I'm Josh.
I'm Josh.
Josh, pleasure to meet you, Josh.
Nice to meet you.
I'm the systems engineer here at Launchpad, and I'm responsible for designing, building, and testing everything you see inside the digital.
That's awesome.
It's incredible. Yoav, can you give us a little bit of the background behind Launchpad? Where did the idea come to be?
Sure. So, I guess to start with, we're a very mission-driven company. We think that it's really important to be able to build products in the US and not have to outsource everything to other countries. And so what we're building over here is really the technology to enable reshoring of American manufacturing using self-programming robots. And the idea, you know, it's funny because we're a mission-driven company, each one of us has come to it from their own place. For myself, I'm a software guy, so building stuff has always been secondary for me. My last company was an energy company, and we ended up building a piece of hardware, which was a smart meter, and it could do some really cool stuff. And it was something that I prototyped myself as a software guy, of course, coding up on a Raspberry Pi, and thought this will be easy now that I've got it working. All I need to do is get a design file, send it to a factory, and they'll make it for me, right? And they did. It just took a year and a half, and it was really, really surprising to me how incredibly manual the entire process of both getting a design validated and confirmed by a factory that they know how to build it, all the way to actually building it, which happens with human hands. That's just the way most things get built. That was really surprising to me. Our CTO Offer, not so surprising to him. His career has been in manufacturing, and he worked at one of the largest manufacturers in the world, and he built all of their internal automation systems, robotic systems. And he developed technology which then he saw being used in sort of the old school way, which is very deterministic. And what I mean by that is you can tell a robot exactly what to do, and it'll do exactly what you told it to do. The problem is that you need to spend a lot of time upfront thinking about it, and then if you told it something that's wrong, it'll just do the wrong thing over and over again. And so the idea of how do we get robots and make them smart so they can make their own decisions was something that we both came to. And we thought, you know, some of the advances in AI, machine vision, computational geometry, this is the time to do it. So we decided to start building proof of concept and built it into the company you see.
When you first had that idea, what were some of the biggest challenges when you first entered in, as you started to build things, or as you started to get your concepts down?
Right.
What was your biggest friction?
The nice thing about building hardware is that it's all hard. So there's friction across the board. It's super, super difficult to build stuff out of real materials and components compared to coding. Coding is much, much easier. And I say this as somebody that is a decent coder and can barely put together some IKEA furniture. But that also sort of guides you to where you need to start. And really it comes down to the technology. There's a lot that can be done using existing ways of doing things. And if that's all we did, I don't think we'd be adding much value to the world. And so that meant that we knew really where we wanted to focus on was how do we make something happen that couldn't happen before? And which approach do we take? And so one of the first things we did was really sit and brainstorm and break the problem down into its components. And where we got to was there was two big things. One was how do I analyze what should happen? In other words, making the decisions. And then the second one is how do I take those decisions and make them work in the real world? And so the analysis is all about computational geometry, about simulation and physics, and figuring out what to do. And so that's one big part of the company, which is the AI and the simulation. And the other one is how do I actually make it happen in the real world, which is really all about machine vision. So how do I take what I've seen in simulation, convert it to the real world using cameras? And so that really, like, those are both very, very difficult challenges. But the good thing is that there's been so much work that's been done on this in the last few years. Our first prototype engine was built in Unreal Engine, which is a computer game engine, right? Now coding up a computer game engine from scratch, super hard. taking an existing one and just writing some software on top of it, not so hard in comparison. And same with the machine vision, the amount of stuff that's happened in the last few years. So both open source packages and stuff we developed on our own. So even though it was quite difficult, by breaking a big problem down into chunks, it becomes easier. The real downside is that you have to do software and hardware together. Just one or the other wouldn't work, because if we only had software, we wouldn't be able to do anything in the real world. And if we only had hardware, we wouldn't be able to create the perfect simulation we need to make those decisions. So that was probably the hardest thing.
Sweet. So yeah, it's really interesting to me, like your background in software, because I also have a background in software. Me and Josh will go back and forth like about like our various viewpoints on things, and it's really interesting, I guess, your perspective, because like what I love about what you're doing is like it comparatively to me, it's like physical automation, almost how you would use software automation, and a lot of what you're also doing seems incredibly modular, almost in the design of software, in that like Josh earlier was telling us that like these come empty and then you all like build kind of these modular components on top of it. And so I guess I was wondering, like, when it comes to like the architecture of these types of physical automations, like where does your software knowledge come into play, or where does it like fail, you know, in certain ways because it is physical and stuff like that?
So that's a really good question. And actually, I guess now that I think about it the way you described it, it makes a lot of sense. Like you think about, so where was software 30 years ago, right? 30 years ago, we were starting to deploy object-oriented architecture. We were starting to deploy reusability of code beyond subroutines. We weren't quite to the model view controller quite yet. We certainly weren't to the kind of microservices architecture or anything like that. All that was developed in the last, let's say, 15 years. Where was manufacturing 30 years ago? Kind of where it is today, right? 30 years ago, we started outsourcing in a big way to countries with low-cost labor, and so I think we sort of we took the sort of the foot off the gas pedal because we found a cheaper way to use labor. I imagine a universe where we hadn't done that. Imagine a universe where we would have continued developing hardware in parallel with software. Maybe we would already have this stuff. And so I guess we shouldn't be too surprised that some of the really clever sort of both structural and management techniques we develop for software can be applied to hardware, but haven't, just like we never applied it 30 years ago. I think maybe there's something to that.
Totally. So what's kind of the craziest request you've gotten, or like craziest experiment you tried with the machines?
Well, so we've run a car through the simulation software. I don't think we're going to be building a car on these machines yet, but that was a lot of components. That was fun. Some product which was not super complicated, but a lot of grease. And so how do you model grease, and how do you model the friction on ball bearings and that kind of stuff? That was interesting. So far, we haven't had anything too dramatically crazy that I can think of. Go for it, Josh.
There's a couple projects now where a lot of companies they have to apply a glue path or an epoxy path, and right now there's a company that wants us to assemble a crystal with a square type glue path on it, and that glue path has to be modeled into the CAD model as a solid part, so it can know the path. And then we got to work in, it's actually temperature controlled and all kinds of stuff. So actually getting it continuously to place that correct glue path is going to be a challenge, because there's going to be thermally controlled. There's going to be pressure inside the nozzle and stuff like that. So getting it to actually not only dispense accurately, but once it's placed, it has to spread at a certain surface area, because it's at a certain viscosity, which is also based on the temperature and all that stuff. So that one's going to be a challenge. It'll be fun, but that one will be a bit of a challenge.
Actually, also the first time that we got a request to do something with the machine that just never occurred to us before, because we built this platform to assemble products, right? Show it a CAD file and it builds the product, because that's what we want to be able to do. And the first time that we spoke to a company that makes huge consumer goods company, and they said, what we want to do to start with is actually laser engraving personalization. Which is super hard because people have to set up the machine, they need to focus the laser and set the fonts and whatever. And isn't engraving a laser the same as, positioning anything and applying anything? It's like, well, I guess it is. We don't know anything about lasers, but let's try. And then we did, and it worked great. And so applying the same sort of logic and algorithms technology to something we'd never thought of before, that's almost business as usual now. But, first time that happened, that was kind of wild.
Sweet. Yeah, Josh and I were talking about earlier how like I was comparing it again to the scripts that I write in software, but he was like in a script in software, like you can't get your hand stuck and then like get hurt physically unless of course you're typing and get carpal tunnel or whatever. But it's very different. And so I guess like has there ever been any situation, especially with lasers, where like you definitely don't want to have your hands caught in there? I would just be scared that I'd accidentally almost hurt myself.
This machine, maybe not necessary for lasers, but a lot of these machines, they run on pneumatics. So we have a lot of pistons that are extending and retracting parts. And during testing, you're not running everything automated, right? So you're doing stuff manually, and sometimes you kind of get a little complacent. And there's been times, I've been working on something, and you have to hold something extended for a minute, and you're like, oh, I get it, and your hand slips, and it's in the way, and then it comes back, and it pinches you, or it gives you a little something. On the lasers, we have them outfitted with the laser protective glass so that you can stare at it without going blind. But you could probably, so our main laser is a UV laser. I venture you could probably give yourself a nice little tat with it, but I haven't given it a try yet. I wouldn't recommend it. But yeah, you definitely don't want the hood open or your hands anywhere near them lasers, because it'll probably do some damage.
When you deal with hardware, it's second nature to take things a bit more seriously than with software, because move fast and break things with software. When you break it, you just restart. When you break something in hardware, it takes you half a day to clean up. So it's a different mentality.
Totally. That makes a lot of sense. People should probably care that much about their software too sometimes. Yeah.
But also, look, the nice thing about software is you get a whole bunch of testing with minimal effort, right? You write some unit tests and they run. That's another reason hardware's hard. It requires a slightly different mindset. But at the same time, if you can take the software mindset and bring it to hardware, you can think about lots of problems before they even happen. So I think there's good elements from both.
Totally. It's true.
You mentioned laser engraving being something that you learned kind of because your clients mentioned that that's what they wanted. Were there any other learning lessons, something that you've never dived into before, that because of the client and their constraints and what they wanted, you were kind of forced to learn?
Yeah, not so much forced to learn, because we have a whole roadmap of things we're going to build. And one of the things about being a startup, you can't build everything up front. You have to build it. You have to fly the plane while you're building parts of the plane. And so the order in which we build the plane is when things are required, because that's what the customer wants. And so we did a few projects with O-rings. O-rings are not that easy because they're semi-flexible and quite difficult to model. And so we actually put that a little bit further along in our roadmap. But it turns out a lot of customers want that now. And also, the world has changed so much in the last couple of years. I think we all know that. And so what people wanted 2 years ago isn't what they want today. The kind of problems that people are trying to solve today are very different to the problems they were solving 2 years ago. Not because products have changed, but because certain kinds of people are super hard to hire right now. Every one of these machines is going to companies where people, they can't find enough people to build their products. No one's getting fired when one of these machines comes in. What's happening is they're taking somebody who is currently working 12 hours a day assembling a boring screw and moving them to a much more interesting part of the product line. And so we're really solving some of these fundamental issues a little bit faster than we thought we would, just because it's so hard to hire people now.
So one of the things Josh was telling us about earlier is that, like, one, you can daisy chain all the machines together, which is really freaking cool. And then also that, like, if you had a customer that wanted something huge, you could just scale it up. And I guess my question would be, like, what's your, like, dream customer if you wanted to, like, really build something cool?
Yeah, no, those things are exactly right. And we'd love to find customers that needed our exact machine as is and a bunch of them to chain together. That'll be great because we already have it out of the box. But also we'd love to find some customers who needed something which was outlandishly large, because we think the architecture supports it. And we think that it's really important for us to show that this isn't just something that applies to just electronic assemblies or something that applies to just mechanical assemblies or whatever. We think that in principle, this is how everything should get built. And so we'd really love to find some of those. We think that, hopefully we'll have a couple of larger machines pretty soon building things like doors and windows and that kind of stuff, which is, miles apart from building electronic devices. At the same time, I think that we'll find some customers in the space and aerospace sector, super small devices, really high precision, where getting it right first time is super important to them. And so, yeah, we're really excited to get both of those.
A space project would be that's my dream. NASA NASA, SpaceX, any of those, anybody doing. Then you got Lockheed, Boeing, anybody that's doing anything in space, top super secret squirrel, cutting edge type stuff. That's what I want to be a part of. I want our digital to be on the forefront of the cutting edge of automated assembly.
And look, when we have space habitats, when we have a base on Mars, when we have a base on the moon, you're not going to have Shenzhen around the corner to build stuff for you, a container away. So
3 or 4 shipping weeks.
Right. You're also not going to have 100,000 low-cost laborers on the moon ready to build stuff for you. So this is what needs to happen. There's no question about it. Like if we actually want to explore space and do it properly, we're going to need to have this kind of technology. It has to happen. And it has to be this way. There is no other way. Like the idea that we're going to be able to create custom automation lines in situ that takes 6 months to put together. No, it's going to have to be flexible. It's going to have to be modular. It's going to have to build one thing 1 hour, another thing the other hour. And 3D printing was like the promise of this, right? That was like when you mentioned 3D printers, we think, oh right, yeah, because you can print anything. And it's like, yeah, you can print any components. But if you want to build a product, what products do we have aside from like a coffee cup that is one component? Practically everything is a bunch of components need to be assembled together, and a 3D printer doesn't do that.
So back when I first started college, there was an event that happened where NASA was on a call with the space station, and they were talking about an issue. The space station was talking about an issue they were having, and on that call there was a third party, a 3D printing company. And the guys on the space station were like, "Yeah, man, we got this thing, we can't get to it. We need a tool that allow us to do this." And the third party was like, "Oh, we could print you that tool." So what they did was the space station was actually outfitted. It had a 3D printer on it. So what these guys did, man, they just modeled it up and then sent it and emailed the space station their tool. And then they printed it. It was a small little socket wrench, and they printed it up there on the space station and then used it. And my mind was blown. I was like, "You literally just sent data into space and then converted it into a solid object to be used as a tool." And I was like, it was unbelievable. And then it took off from there. And I'm kind of hoping we can kind of get the same thing going with these digitals.
Absolutely.
Which is not as outlandish as it sounds, right? So one of the big challenges when you're designing a product. So the designer will design the product, and when they're done, I'm exaggerating a little bit, they'll sort of throw it over to somebody to make the product. And that's part of the reason it takes so long, is because you can design anything in CAD, right? Especially if you've got good CAD software, you can design anything. But it doesn't mean that it can get made, either because the components can't get made, or even more likely is because the components physically can't be assembled into a final product. And one of the things that our software does is it actually gives you this kind of feedback live. So you show it a CAD file and it'll tell you this component can't get made. These 3 components need to be assembled together, but they can't. There's not enough clearance for a tool to get in and a tool to get out. Or this combination of screws, you can put them in, but it can't be disassembled, or whatever it might be. And all of this stuff today is done through the experience of a person. And if the experienced person isn't there, or if the experienced person is busy, which is typical, it takes a really long time, and it really adds to the product product development life cycle. And so we think that if you turn this stuff away from experience and into actual simulation and software, it'll dramatically speed up how quickly we develop products, and also make it so that we can develop better products.
I really like that you bring that up, because back in my mechanical engineering days, you could tell those that were a novice mechanical engineer versus those that were an expert based on the manufacturability of a part. Is that you're right, we can design anything we want in CAD. I can make a dragon out of steel, but to actually physically make that part becomes a huge challenge. And so I really like that you bring that up, because it does demonstrate the art of hardware design.
You have to make the part and send it to somebody, and or you design it, then somebody makes it, then you test it. In that scenario, say you have an assembly line that you're already putting things together, doing some assembly, right? Or you're doing testing on a new product. And you run it through the assembly line, then you test. Now you have we got to make a design change. Now you got to redesign the part. Now you have to redesign your entire line to compensate for the new geometrical change on the new part. But with our digitals, you don't have that problem, because you upload the CAD file. It'll tell you if we can put it together. It'll tell you how it'll put it together. If there's any issues, it'll let you know. And then once you get it all together and it's working, say you have changes down the line, all you have to do is make the changes in the CAD file and re-upload it. and the software will say, hey, nope, you're good to go. Or if there's changes that need to be made, the software will catch all that and highlight, okay, you've made this change, so you're going to have to make this change now on the machine, or change this parameter or something like that, and it'll catch all that for us. So it really, increases the modularity of the system, going from one project to the next without having to completely revamp everything.
That's
And anyone watching this obviously won't have first-hand experience of this, but think about the way we used to code, right? Today we take it for granted, write some codes, hit compile, run it. That's not how it used to work, right? It used to be that you wrote the code, it got turned into punch cards. Those punch cards would get driven to a building and run in a computer, and then the next day or 2 days later you'd get your set of errors and you would redo it. That's how, and it took forever to develop software, right? But that's hardware. That's how it works today. Because you don't have that real-time feedback. Not having real-time feedback kills innovation. Somehow we made it work with hardware, but that's why hardware's so hard. So if we have this kind of stuff, if we've got good CAD working together with good simulation working together with good robots, we're going to be just astonished at the kind of products we're able to make and how quickly we can develop them. Super exciting future.
No, totally.
Absolutely.
That's something I love to think about, just because I feel like as a programmer myself, it's cool thinking about how much you can build just yourself in a weekend. And with hardware, that feeling for me isn't there, but it could be in this future that we dream about, where everything is automated and very aligned. It would just be awesome to just whip something up on a weekend.
Yeah, it really would, because when from the creative space, you're always thinking, you're always thinking about problems you have. Oh, can I make a thing that solves this? Or can I make a thing that solves that? You're like, oh, I could, but I got to do this, I got to do this, I got to do this. If you cut down on all of this that I got to do, like she's saying, oh, let me just whip it up in a weekend, build it, test it, and then, it's like the possibilities are endless at that point.
And by the way, if we really want to get into this generative design stuff, which is just so exciting, right? We're seeing it in images and we're seeing it in text and we're going to see it in video, but we're not going to see it in anything real unless we can close the loop between what is the 3D model that, looks good on a screen, but one that actually works in the real world. And if we can't close that loop, it'll never happen. But if we can close that loop, it'll just happen. And now, if you want to design a new product, in principle, you could just talk to a machine, tell it what you want, and it'll design it for you. And then you as the human will edit rather than come up with things from scratch, which should also be just, mind-blowing, again, compared to what we're seeing with ChatGPT and Midjourney and everything else.
Thank you for having us today. We had an amazing time. We love the technology. We have 6 last questions to rapid fire at you really quick.
Bring it.
Let's do it. What's your favorite artist?
Music artist?
Mm-hmm.
I'm a bass head, so probably Avicii, Steve Aoki, any one of those
Cool.
guys.
Love it.
I don't know who that is. Frank Sinatra. That's my.
Nice.
Okay.
What's your favorite tool brand for pliers or whatever?
A lot of people are going to hate me for this, but I got Snap-on's pretty good tools. I like Snap-on.
I'm a software guy. I like my Apple.
What was your favorite toy as a child?
Kinects and Legos.
I didn't have toys when I was a child.
What?
Yeah, no, my parents never really bought me any toys, so I made my own. So, made my own stuff, made my own
The
software.
builder started.
Yeah,
early.
no, seriously. That's true.
Right.
Yes. Sad childhood. Yeah.
That's cool.
No, not at all.
The first computer you ever used?
Windows 95. It was an HP Hewlett. It was a Hewlett Packard, and it was running 95. Windows 95.
Ha ha ha. This is more my wheelhouse. Let's see. The first computer that I ever used was probably an 8086, like the original IBM PC. The first one that I really fell in love with. Then there was a 286 that wasn't so great. The first computer I fell in love with was a PS2, which was a PC that IBM made that had a modem attached. This was when I was 9 years old, and this was pre-internet. But then learned to use the modem, dial into bulletin board systems, and that's why I learned how to program. Self-taught everything from that.
Nerd.
Yeah.
Nice.
Built my first computer when I was 13.
Ooh, that's
Yeah.
cool.
Oh my gosh.
Favorite or dream car?
Go ahead.
No, I sound really sad. So I switched to electric 15 years ago.
Wow.
Yeah, this was pre-Tesla, and I've been driving electric cars since. And so
Wow.
it's only electric, and so I drive a couple of Teslas now, and good enough for me.
A man of the future. That's right.
So I'm a big Audi guy. So I would say the R8, but with the
Nice.
way Audi's going with their electric cars and all this stuff, like the e-tron looks pretty gnarly. But if we're talking dream car, I want something with some horsepower, with some sportiness. Like I'm talking like an R8 or a custom built Vet or anything that's got some power behind it.
Very cool.
Favorite computer game or any game?
I gotta say it's either right now it's between either Call of Duty or Hogwarts, man. It's a toss up.
There's there's the popular choice, and then there's the deep choice.
Yes.
So,
Here we go.
Favorite ever. It'll probably be Civilization. One of the Civilizations, 3 or 4 is probably the best. I play a lot of Age of Empires nowadays. Age of Empires 4, again, very deep cut when it comes to computer games. But actually, my favorite is probably Factorio Satisfactory, which sadly enough is a computer game where you build factories.
It's so dope.
I just
Yeah.
heard
It's
about
so
it
dope.
yesterday
Yeah.
We
from
talk about it a
Jess.
lot,
Yeah.
yeah.
That's
Yeah.
amazing.
Yeah, Factorio Satisfactory, Dyson Sphere program, all
Dyson Sphere,
all
so
within
cool.
all within the genre. Dyson Sphere program, 5 programmers wrote that entire game. Unbelievable.
It's beautiful graphics.
Yeah.
Like it's so cool.
Yeah.
So it's not Civ, but I can go back and tell you about Halo. Halo's probably, if we go back in time, well, not as far back as you go, but
Well, that's all the questions we had for you. Thank you again for having us. It was wonderful, and look forward to hearing from you in the future.
excellent. We
Great.
look forward to it. Quick question: do you know what questions they're going to ask you? Oh, okay. Okay, that was really good.
Yeah.